What's the matter, Sylvia?
Every day we receive millions of observations here in this room. Observations from satellites flying about 800 kilometers above the Earth, looking at the atmosphere. These data come from European, American, Japanese, even Chinese space agencies. We also receive observations from the surface, like measurement stations all over the world, ships, airplanes, etc. We receive this data continuously, 24 hours a day, 7 days per week, and this data, incoming data, is being monitored in this room. We make sure the data arrive on time, that there's no problems. We archive the data immediately to make sure we have the data when we need them. And this is all being monitored by the people here in this room to make sure that if there's a problem, because the data transfer is not correct, there is a problem with the satellite, a problem with the observation station, we know about it and we can fix it if we can. The data is then looked at for quality control. We make sure the quality of the data is good for our purposes before we actually start using it in our systems.
So there's the observation, comparison with getting outbursts getting smaller and smaller. Yes. So this is no way you can pick up the negative boundary layer or something. Yeah. So there's the observation, comparison with
This is comparing with one of Johannes's model forecasts.
The green line is a model forecast.
Yes.
The red one is
they're both model forecasts for the top of it. I mean,
Fine to keep it, but
well, not necessarily. And then you have to scroll down then whenever you change.
yeah.
Among the various pollutants that we study, there is, for example, dust from the desert. We can see here a nice, beautiful image of a dust plume coming from the desert and wrapping around and going towards southern Europe and affecting air quality in these regions. How do we get a forecast from this data? The data are elaborated on the supercomputers using sophisticated algorithms that mimic the law of physics. The forecast for yesterday is then compared with the observations of today to produce the forecast for tomorrow. And we can see here a visual realization of the forecast. This is the same dust plume, but this is not the satellite image, it's the actual forecast. And we can see the plume, again, wrapping around Europe and affecting air quality there.
It's the one I put up.
There are various users who can benefit from our forecast of air quality. You can think of citizens who are sensitive to high levels of pollution, like people with asthma, who need to know what the conditions will be for the next few days. There are authorities in cities or regions that need to change, for instance, traffic control based on air quality measurements, but can use our forecast to anticipate the situation. There are authorities in regions or countries who want to be aware of the transboundary transport of pollutants so they can adjust their measures based on that information. And there's the scientific community that's very interested to look at the interaction between human activities and climate through pollutants in the atmosphere.
hier landen. Und es wird jetzt hier dank einer Zyklone hier, haben wir jetzt eine Vorhersage ausgenutzt, die ein Jahr Tag anfängt, an die Aschauer, und zum anderen, dass möglicherweise dort wieder ein Containerschiff hat, die Mission von einer mittleren Kleinstadt.
On the other hand, the work of
So we are in the midst of Duisburg right now, at Duisburg-Bruckhausen. That's one of the areas worldwide with the biggest factories for integrated steel production. And we are observing the air quality here in order to observe whether they are reaching dangerous levels for your health. Behind me you can see the air quality measurement station, and behind that you can see the integrated steel mill, one of the biggest that exists in the world. One thing that we are doing with the data that we are collecting here is we use them to report to the European Commission. And the other thing that I'm doing with that data is to give it to the University of Cologne and the research center Jülich, so that they can put it into their regional air quality model in order to improve their forecasts. They are doing it by data assimilation.